In the previous video, we have covered the introduction part from current electricity. Now I will explain about charge carriers. In conductors, what are the charge carriers? Charge carriers are free electron. I will explain what is free electron. Not all electrons are free electrons. Basically, conductors are having less 3 or less than 3 electrons in their outermost orbit. So let's say this is an atom having a nucleus and we have other shells, and let's say this is the outermost shell. Now if number of electrons in the outermost shell are 3 or less than 3, for example, with aluminium it is 3, with copper it is 2, with silver it is 1. Now when the number of outermost electron is 3 or less than 3, those elements can behave as conductors, or those elements will allow current to pass from one position to another position. Why is that? The reason is the electrostatic force of attraction on the outermost electron by the nucleus. So nucleus will be attracting these electrons inward. Okay, now whenever number of electrons are less in the outermost orbit, then the force of attraction will be less, or these electrons can simply come out. Now these electrons are bound electron whenever they are in the outermost orbit, but whenever these electrons come outside, so what will be the reason? The reason is, if someone is providing an energy, it can be in the form of heat, or it can be in the form of for example photon. So whenever it is getting additional energy, what will happen, you know? What is the energy of moving electron? Half mv square. Now when it gets energy, its velocity will increase, and after that it cannot maintain in this path, or it cannot revolve in that path. It will try to escape out of this path, or basically that will come out, or these electrons are free electrons. Now these electrons doesn't belong to any of this atom. Basically this has came from an atom, but after that it has no connection with that parent atom. These electrons are free to move. When it will move, whenever, so let's say this is a free electron. When we are providing an electric field, let's say I am placing a positive charge here, so these electrons will be able to move in this direction. Now I have told you here that whenever these outermost electrons are getting energy, then only this electron will come out. So heat is a form of energy. So the option is, we can heat an element so that these electrons will come out from the outermost orbit, and that will become free. But the thing is, by nature, with atmospheric temperature, all the conductors are already in excited state or already heated. Let me explain it to you. Now what is atmospheric temperature? 27 degrees Celsius, right? When I am measuring in Kelvin, that is 300 Kelvin. What is absolute zero? 0 Kelvin. Now see, basically when we are keeping an element in atmospheric temperature, it is already heated to 300 Kelvin, or those are already in excited state. Or I can say that there are a lot of electrons which are free electron. For example, the amount will be approximately 10 to the power 29 number of electrons per meter cube. In a meter cube box, there will be approximately 10 to the power 29. So these many electrons are there with conductors when it is at atmospheric temperature. Now these electrons can contribute for the conduction. In the case of insulators, these free electrons are not there. In the case of semiconductors, what are semiconductors? In semiconductors, there will be 4 number of valence electron, and innermost orbits are there, and we have a nucleus. So generally it is difficult for this electron to come out even at 300 Kelvin, that is at atmospheric temperature. But when you are increasing the temperature beyond this, after a limit, what will happen? These free electron will come out, and that can behave as a charge carrier or as a free electron. So basically semiconductors are not conductors or doesn't conduct electricity at room temperature, but at higher temperature they can conduct electricity. Here in this case, these conductors can conduct electricity at any temperature, but lower the temperature, the I mean, there is one more relation. I mean, how the conductivity is connected with temperature, I will explain it to you. But anyway, at room temperature, these are conductors, but these are not conductors. Okay. Now, no, not only electrons are charge carriers. We have ions as charge carriers. For example, in a NaCl solution, so these are anode and cathode. So I am connecting a battery here, positive terminal, then a negative terminal, and we have NaCl solution here. This is an electrode. Okay. Now here electrons are not in transport. NaCl will be split into Na plus and Cl minus. Now Cl minus will go to the positive terminal and Na plus will go to the negative terminal. So what are charge carriers here? Ions are charge carriers. So basically in solutions, ions are charge carriers. In conductors, free electrons are charge carriers. Now what will be in the case of gas? Gases are basically insulators, but gases can behave as conductor after their breakdown. Okay, there is something called as dielectric strength. What is that? Let's say, I have explained you this in potential, I think, but I will explain it to you again. Let's say we are increasing the charge of a shell. Okay, we are adding charges to a shell. So what will happen? One more thing, surrounding to the shell we have air particles. So air is nothing but a gas, and these are insulators. Now whenever we are increasing the positive charges here, air particles are equal positive, they have equal positive and equal negative charges. So basically they are neutral. But when we are increasing the charges, see, these positive charges will try to take an electron from this. Clear? So it cannot easily be accomplished, but after a limit what will happen, this will be able to capable of taking an electron from this, and thereby it will become ionized, and these ionized air particles can contribute towards the conduction. So this is a special condition where pressure of the gas should be less and this should be at higher electric field. So electric field should be very high and pressure should be less, so that we can ionize a gas and that will act as a conductor, or that can contribute towards conduction of charges. Okay, that's all.